Welcome to the course on Design of Reinforced Concrete Elements. In this session, we are going to see about the Introduction to Limit State Method. Introduction. Working stress method gives a satisfactory performance at the working loads, but no attention is given to the conditions that arise at the time of collapse of the structures. Because we are considered the stress strain curve for the material is up to the elastic limit only. This method does not give the exact margin of safety. So this drawback was taken into account in the ultimate load method or load factor method. But load factor method leads to excessive deflection and cracking. A more rational approach is given by the limit state method of design, which is balanced combination of working stress method and ultimate load design method. Limit state concept. Aim of this method is that the structure should be able to withstand safely all the load that are liable to act on it throughout its life, and it should also satisfy the serviceability requirements of limiting deflection and cracking. So the limit state is defined as the acceptable limit of safety and serviceability requirement before the failure. The most important limit state which are considered in the design as are follows: limit state of collapse and limit state of serviceability. First one, limit state of collapse. This limit state is also called as the strength limit state because we have considered as a maximum load carrying capacity of the structure. The limit state of collapse is assessed from the collapse of the structures of a whole or part of the structures. As this limit state, the resistance to bending, shear, torsion and axial loads at every section shall not be less than that produced by the most unfavorable combination of the load. So combination of the load means the combination of dead load plus live load plus live load plus wind load, or dead load plus live load plus wind load plus earthquake load. This is a combination of loads. So the following limit state of collapse are considered in the design: limit state of collapse in flexure, limit state of collapse in compression, limit state of collapse in shear, limit state of collapse in torsion. The next topic is limit state of serviceability. A structure is of no use if it is not serviceable. Serviceability, if it is not serviceable, the structure is of no use. Thus, this limit state is introduced to prevent the deflection and cracking. It ensures the satisfactory performance of the structures at working loads. It is estimated on the basis of elastic theory or working stress method because the deformation is significant under the working load conditions, not at the collapse. So the limit state of serviceability is limit state of deflection and limit state of cracking. The next one is comparison of working stress method and limit state method. Working stress method, the first one is a working stress. This method is based on the elastic theory. Assume both concrete and steel. Assume that concrete and steel are elastic. So stress strain curve is linear for both materials. So stress strain curve, this is a stress and x-axis is a strain. So stress strain curve is a linear. We are assume like that. But in case of limit state method, it is based on the actual stress strain curve for the steel and the concrete. For concrete, stress strain curve is a non-linear. The, uh, the stress strain curve for the concrete and concrete for non-linear. This is a non-linear. Stress and strain curve is a non-linear. Actual stress strain curve for concrete is a non-linear. And the second one is this method of factor of safety are applied to yield stress to get a permissible stress. So permissible stress equal to yield stress divided by some factor of safety. This method, partial safety factors are applied to get design value of stresses. And next one, no factor of safety used for the loads. But in case of limit state method, design loads are obtained by multiplying partial safety factors of the load to the working load. So working load multiplied by the factor of safety. Then next one, exact margin of safety is not known. Exact margin of safety is known. For in case of limit state method, exact margin of safety is known. The next one is, this method gives a thicker section, so less economical, but this method for the limit state method gives a thinner sections, so economical sections. We have designed by using this method more economical sections. This method assumes that actual load, permissible stresses and the factor of safeties are known. So this method is called as a deterministic method. But here it is limit state method is based on the probabilistic approach, which is depending upon the actual data and the experience. Hence it is called as a non-deterministic method. The next one is characteristic values and design values. Refer the IS 456 class 36. Characteristic and design values and partial safety factors is given in the class 36 in IS 456 2000. 36.1 is a characteristic strength of material. Characteristic strength of materials. The term characteristic strength means that the value of the strength of materials below which not more than the 5% of the test result are expected to fall. So the characteristic strength of the concrete is given in the table 2. This is the characteristic strength of the concrete. Specified characteristic compressive strength of the concrete 150 mm size cubes at 28 days. So ordinary concrete, normally the concrete are classified in ordinary concrete, standard concrete and high strength concrete. So already this table we have discussed in the previous session. So this is the grade of concrete and the characteristic compressive strength of the concrete. Normally the reinforced concrete materials, one is a steel and another one is concrete. So the concrete grade of concrete is given in the table 2 and grade of steel, characteristic strength of the steel shall be assumed as minimum value of yield stress divided by 0.2% of proof stress. So this is the characteristic strength of the steel. Characteristic strength of the steel is taken as minimum yield stress. Minimum yield stress or 0.2% of the proof stress specified by the various Indian standard. In case of mild steel is taken to minimum yield strength of the steel. Suppose in case of HYSD bars, high yield strength deformed bars is taken as equal to 0.2% of the proof stress. So this is considered as a characteristic compressive strength of the steel. Then characteristic load. The term characteristic load means the value of load which has a 95% probability not being exceeded during the life of structures. Since data are not available to express the load in statistical term for the purpose of the standard, dead load is given in the IS 875 part 1. Imposed load, these also already we have discussed in the previous session. Dead load, live load. Next one is a live load or imposed load, IS 875 part 2. Wind load is given in the IS 875 part 3. Snow load, IS 875 part 4, and seismic forces is considered as a 1893. So the term characteristic load means the value of load which has 95% probability of not being exceeded during the lifetime of structures. Absence of any data, we have to consider as per the IS codal provision. Next one is a design value. This is already we have discussed based on the IS codal provision. Characteristic strength of materials means in our design we have used concrete and the steel materials. So characteristic strength of the steel is given in the table 2 and characteristic strength of concrete is given in the table 2. Steel is minimum yield strength of the steel is considered as a mild steel, or HYSD bars means 0.2% of the proof stress is considered as a characteristic strength of the steel. And the characteristic loads also we have discussed. If there is any data as per the codal provisions, we have considered as a dead load and live load or imposed load, snow load, wind load, everything we have considered as based on the codal provisions. The next one is a design values. Design strength of materials and design load. Design strength of materials and design load. Partial safety factors for the materials. So the next topic is design values. The design value is given in the table IS 456 2000 36.3 36.3.1 material. The design strength of the materials FD is given by FD equal to F divided by gamma M. Design strength of the materials FD equal to F divided by gamma M. F means characteristic strength of the materials and gamma M means partial safety factor appropriate to the material and limit state being considered. So FD equal to F divided by gamma M. F is a characteristic or FCK. Normally we have written like that, FCK. Characteristic strength of the materials divided by partial safety factors. In case of design load, the design load FD is given by FD equal to F into gamma F. Characteristic load, capital F is a characteristic load. Characteristic load is based on the codal provision 875 part 1, part 2, part 3 and snow load, seismic load based on the IS codal provision if there is any data. And gamma F means partial safety factor appropriate to the nature of loading and limit state being considered. Gamma F means partial. Next one is a partial safety factors. So based on the design loads or design value of materials or design loads, we have considered the partial safety factors. So gamma F is given in the table 18. Partial safety factors for the load. This is the load combination, dead load, live load, dead load plus wind load, dead load, live load or wind load. So this is a combination of the load. Dead load and live load is multiplied by the 1 plus and wind load is multiplied by the 1.5. This is multiplied by 1.5. This is multiplied by 1. For this is for the limit state of collapse and this is for limit state of serviceability. So partial safety factors for the materials. When assessing the strength of a structures or structural member for the limit state of collapse, the value of partial safety factors gamma m should be taken as 1.5 for concrete, 1.15 for the steel. So partial safety factors for the concrete is 1.5 and steel is 1.15. A higher value of partial safety factor for concrete, 1.5, has been adopted because there are greater changes in the variation of strength of the concrete due to improper compaction, inadequate curing, and variation in properties of ingredient. But in case of steel, partial safety factors for the steel is 1.15 because the changes of variation in the properties of steel are very small because it is fabricated in the industry. So, and good workmanships and better quality control can be achieved. So that is the main reason partial safety factors for steel is small, 1.15 for the steel we have considered. So this is also discussed, design strength of the materials and design loads. So both are, we have divided by the some partial safety factors. So partial safety factors for the steel and concrete is 1.5 and 1.15 respectively. The next one is, these are the questions may be asked from this topic, multiple choice question. The first one is here, the acceptable limit of safety and the serviceability before the failures occurs is called. Acceptable limit of safety and serviceability before failure occurs is called as the option A, limit state, failure state, and ultimate state. Not state, ultimate state. This is not a state. So answer for this question is, the limit state method only we have considered both safety and serviceability point of view. We have designed based on the limit state method. So the answer is limit state. The characteristic strength of the steel. The characteristic strength of the steel is for mild steel. Characteristic strength of the steel is where mild steel considered, it is equal to the minimum yield strength of the steel. Or for HYST bars is taken to 0.2% of the group stress. So here it is, there is no mention in the type of steels, mild steel or HYST bars. So characteristic strength of the steel is yield stress is considered as a characteristic strength. The third one is here. Third question is, the value of partial safety factors for the steel is 1.5 for the concrete. Concrete is partial safety factor is high because we need not to maintain the quality of concrete. Lot of changes, variations in the quality of materials and curing. So that's why we have considered here 1.5 partial safety factor. For steel is 1.15 is for steel. So the answer is 1.15. The value of partial safety factors for the concrete is, the next question is 1.5. Already we have discussed. The last one is here. The value of partial safety factors for the dead load and the live load is 1.5. This is given in the IS 456 table. So partial safety factors for dead load and live load is 1.5. So this is the answer. So the answer is 1.5. It is given in the table IS 456, table number 18, page number 68. So table 18, IS 456 2000. This is given the combination of load factor, dead load plus live load. Partial safety factor is 1.5. Thank you.